Hello sir, myself Moyajjan Molla from second year EC department. Today I will discuss about amplitude modulation. Now I talk about content. Before learning about amplitude modulation, we need to know what is the amplitude modulation, types of amplitude modulation, mathematical expression of amplitude modulation, modulation, index of amplitude modulation, mathematical expression, equation of amplitude wave, bandwidth of amplitude modulation, power efficiency. Before learning about amplitude modulation, we need to know what is modulation. Modulation is a process. It is vary the frequency, amplitude, phase of carrier in accordance with the instantaneous value of message signal, carrier signal. The signals that contain no information but have a certain phase, frequency, and amplitude are called carrier signals. Modulated signals, the signals which are the combination of the carrier signals and modulation signals are modulated signals. The modulated signals is obtained after the modulation of the signal. Why modulation is used? Length of antenna. When the signal is transmitted wirelessly, then the size of the antenna is very important parameter. So this size of the antenna is proportional to wavelength of the transmitted signal. Let say size of the antenna L is lambda by 4. Now relationship frequency of the wavelength lambda is c by 4, where c is speed of light, f is frequency of the transmitted signal, lambda is wavelength of the transmitted signal. For example, a transmitted signal has frequency 10 kHz, then lambda is c by f equal 30,000 meter. So size of the antenna equal lambda by 4 equal 7,500 meter. Point number 2, frequency multiplexing. It is practically not possible to distinguish between the different audio signal when transmitted simultaneously through a signal antenna, as all of them lie in the same spectral range. Hence, each of these signals is translated to a low frequency range before transmission, which makes it quite easier to recover them and distinguish each of them from one another at the receiver's end. Point number 3, narrow banding of signal. An audio signal usually has a frequency range 20 Hz to 20 kHz. If it is directly transmitted, then the ratio of the highest to the lowest frequency become 100. But if this audio signal is modulated over a carrier signal of frequency 1000 kHz, then the ratio of the highest to the lowest frequency becomes 1.2. What is amplitude modulation? Amplitude modulation is a modulation technique used in electronics communication, most commonly for transmitting messages with a radio carrier wave. In amplitude modulation, the amplitude signal strength of the carrier wave is varied in proportion to that of the message signal, such an audio signal. Types of amplitude modulation. Amplitude modulation are mainly three types. Single sideband modulation (SSB). The SSB amplitude modulation is a standard method to process sideband on only one side of the carrier frequency. The amplitude modulation can produce sidebands on both sides of the carrier frequency. In SSB, it uses bandpass filter to discuss on sideband. The SSB modulation process improves the bandwidth utilization, and total transmission power of the transmission medium. Double sideband suppress carrier modulation is DSBSC. Double means two sidebands. The frequencies produced by the AM in DSB are symmetrical about the carrier frequency. The DSB is further categories as DSB, SC and DSBC. The DSB-SC double sideband suppress carrier modulation does not contain any carrier band, due to which its efficiency is also maximum as compared to other types of modulation. The carrier part in the DSB-SC is removed from the output component. The DSB-C double sideband with carrier consists of the carrier wave. The output produced by the DSB-C has a carrier in combination with the message and the carrier component. Vestigial sideband modulation VSB. Some of the information is SSB and DSB may get lost. Hence, DSB is used to overcome the drawbacks of these two types of amplitude modulation. Vestige means a section of the signal. In VSB, a section of the signal is modulated. Mathematical expression of amplitude modulation. Sinusoidal modulating signal or message signals S of t of frequency omega m and amplitude am given by S of t equal am sin omega t omega mt, where S of t equal modulating signal, am equal maximum amplitude of the message signal, omega m equal frequency of the message signal. Carrier wave C of t of frequency omega c and amplitude AC given by C of t equal AC sin omega ct, where C of t equal the carrier signal, AC equal maximum amplitude of the carrier signal, omega c equal frequency of the carrier signal. What is modulating index? Modulating index, it is defined as ratio of maximum amplitude of modulating signal to the maximum amplitude of carrier wave signal. Modulating index mu equal a m by a c, where mu less than 1 under modulating, mu equal 1 critical or perfect modulation, mu greater than 1 over modulation. Mathematical expression. Message signal S of t equal am sin omega mt, carrier signal C of t equal AC sin omega ct. Using the above mathematical expression for message signals and the carrier signals, we can create a new mathematical expression of the complete modulated wave. The amplitude modulated wave A is given as A equal AC plus S of t. Equation number 3. Put A value from equation number 1 into equation number 3. A equal AC plus AM sin omega mt. Equation number 4. The instantaneous value of the amplitude modulated wave can be given as A equal A sin theta. A equal A sin omega c t. Equation number 5. Put A value from equation number 4 into equation number 5. We get A equal AC plus AM sin omega t omega mt into sin omega ct. Equation number 6. We know that mu equal AM by AC. AM equal mu A. Putting this value of AM in above the equation 6, we get A equal AC plus mu AC sine omega IMT into sine omega CT equal AC sine omega CT plus mu AC sine omega MT into sine omega CT. Equation number 7. A equal AC sine omega CT plus AC mu half cos into omega C minus omega M into T minus AC mu half cos into omega C plus omega M into T. Equation number 8. In this above equation, the first term represents unmodulated carrier, the second term represents low sideband, and the last term represents upper sideband. Equation of amplitude wave. Note that mu c equal 2 pi fc and omega m equal 2 pi fm. Hence, the above equation can be also be written as A equal AC sine 2 pi fct plus AC mu half cos 2 pi into fc minus fm into t minus AC mu half cos 2 pi into fc plus fm into t equal AC sine 2 pi fct plus AC mu half cos 2 pi f LSB T minus AC mu half cos 2 pi F USB T. These contain the full carrier and both the side bands. Hence, it is also called double side band full carrier system or DSBFC. The bandwidth of amplitude modulation. The bandwidth of signal can be obtained by taking the difference between the highest and lowest frequencies of the signal. Bandwidth equal FUSB minus FLSB equal FC plus FM minus FC minus FM equal 2 FM. Power efficiency. Power efficiency equal P USB minus PLSB by FC plus FLSB plus FUSB equal mu square by 2 by 1 plus mu square by 2. Power efficiency equal to 1/3 into 100%. Thank you.